IBSL Maths, going through the May 2015 exam papers. This is question 4 from paper 2, time zone 1. We have a reciprocal function here. Let's see how we go. F of x equals 2x take 6 over 1 minus x, and valid for x not equal to 1. For the graph of f, find the value of the x-intercept. Alright, well, finding a value of an x-intercept, again, you can use your calculator to do this. Let's do it both ways, just to check it. We've got the time anyway. So if I want to find the value of the x-intercept, I let f of x, the y value, equals 0. You always let y equal 0 to find an x-intercept. So I'm going to have 0 equals 2x take 6 over 1 minus x. Multiplying 3 by 1 minus x, or just knowing that for a fraction equals 0, the numerator has to be 0, doesn't it? So that's the same as saying 2x take 6 equals 0, x equals 3. And we've already got an answer. But it's a calculator test. You'd be mad not to check it. So let's do it. Question module 5. That's what I'm looking for there. So we've got 2x take 6, 2x minus 6. And we are... Oh, didn't work there for me. Dividing by 1 take x. Keep that in brackets too. Remember, when you're putting x in, you use this x. Don't use those ones. They will mess you up. 2x take 6 divided by 1 minus x. Execute. Oh, good. I got a nice view. Remember, if you don't have a nice view, I recommend just going and trying the standard view as a starting point. You can always adjust from there as need be. Again, that's a pretty nice view. How do I solve on my calculator? G-solve using the Casio. Apologies, I don't have a TI or an HP or anything else to go through. This is the emulator I've got, so that's what you're getting. I want to G-solve, and I want to find the root of the equation. And the root of the equation, x equals 3, when y equals 0. So we know we got it right. Still only 2 minutes in, and that was worth, well, something. Probably only one more. Write down the equation of the vertical asymptote. 2 things to note here. Write down, which means it should be pretty obvious. And 2, oh, it's not part B yet. This is question A. Part 2, it's asking for the equation. So make sure you write it as an equation. Remember that vertical asymptote, vertical lines have an equation. X equals a number. What's the only number not valid for? We're not valid in this domain. X equals 1, because of course that would make the denominator 0, and we do not want to divide by 0. So the equation of the asymptote, x equals 1. Part 3, find the equation of the horizontal asymptote. You've got a few options here. You can, of course, just remember that the horizontal asymptote is the ratio of the coefficients of the x terms. So horizontal asymptote is found by y equals the coefficient of the numerator divided by the coefficient of the denominator. So I'm just going to have 2 over negative 1. So y equals negative 2. I really don't like that way. It's not testing your understanding, but it's an exam. You just got to do it. That's how you can go ahead and get the right answer. That's fine. But let's see if we can use a little bit of knowledge and see another way that we could do it that's equally nice, but really demonstrates our understanding. And remember, this is using the same idea as when we complete the square. What I want to do is I want to have 1 minus x as a factor on top. So I outrageously just create a 1 minus x term. Now I'm supposed to have 2x on the top. So that must be negative 2 times negative 1 to create the 2x. But I've also created, by doing that, a negative 2. So even though I have a minus 6, I now need to compensate for subtracting 2 in the creation of that bracket by adding 2. What's that going to give me here? And this is over 1 minus x. What does that give me then? I've got negative 2, 1 minus x, over 1 minus x. So I separate out that term that can cancel. And then I've got negative 6 plus 2 is minus 4 over 1 take x. And you can see that when the 1 minus x is cancelled in that first term, I've got negative 2 minus 4 over 1 minus x. We've already established that this fraction can only be equal to 0 if the numerator is 0. The numerator is 4, it's never going to be 0, is it? So this whole expression f of x must equal something other than negative 2, because it's negative 2 minus this number. Now, even if that number is negative, then it's adding it. That number can never be 0, so the whole function can never be negative 2. So therefore, either way, we can still write down, therefore, the horizontal asymptote is y equals negative 2. And we're done. Finally, find the limit as x approaches infinity of f of x. A few ways you can do that. You can do it algebraically, or you can do it using your calculator and having a look. I'm going to do it both ways, and we'll confirm all these on the calculator in a second. Here we go. Limit as x approaches infinity. What I'm going to do is I'm going to divide or multiply the numerator by 1 over x, and then for the denominator by the same thing. So what I'm going to be left with is 2 take 6 on x divided by 1 over x take 1, and you can see the limit as x approaches infinity is equal to negative 2, because 6 over x is going to go to 0, as is 1 over x. Again, that's just testing a third way of finding this ratio, the equation of the horizontal asymptote. We know that if that's the horizontal asymptote, as we approach infinity, the function's approaching negative 2. Let's check it out. Let's actually exit that and put in an equation, y equals negative 2, and see what we get. Pop that in there. When I draw it now, yes, you can see it's approaching negative 2. Works wonderfully. So the calculator confirms our calculations. Again, you could have just done it on the calculator. Either way is fine. All right, that's that question 4 done. Flying through these. See you in the next one, guys. Cheers.